Okay, so in our previous segments, we have now learned that whenever you add heat to a substance, it can cause it to expand, and that energy from that heat can be stored in that material. So now we want to find out how can the phase or the state of the material change as we continue to add heat to it. So let's go back to our picture of a solid in which we've got these atoms that are being held together by electrical forces, and we represent those electrical forces by springs, or you can think of them as rubber bands that are holding these atoms together. And then as we add heat to this material, what's going to happen is that these springs, these rubber bands, are going to begin to oscillate. And if you increase the amount of heat going to the material, it's going to cause those oscillations to get larger and larger and larger. So what do you think is going to happen if you put too much heat into the solid? In other words, what would happen if you've got a rubber band and you stretch it too much? You put too much energy into that rubber band, well, it's going to break. So what's eventually going to happen is that this solid is going to start to break down into clumps of atoms that are still being held together. So maybe you've got a clump over here that are still being held together by their springs, and then you got another clump over here that is also being held together by their springs, and then holding these two things together are going to be what's referred to as intermolecular forces, which are going to be weaker than the forces that are actually holding those atoms together. So this means that this thing can slide over the top of this one, and so these clumps can move around. And so now what we've done is we've gone from a solid to a liquid. And then if we continue to add heat to it, then eventually these individual springs are going to break down, and then you're just going to have isolated atoms and molecules. And then that is going to be a gas. And then you can still add even more heat to it. And if you add more heat to this gas, then what's the next thing that's going to happen is that the electrons are going to pop off. So remember that each of these atoms is going to have a positive nucleus, and then it's got an electron in orbit around it. So if you add enough energy to an atom, it will cause that electron to come off the atom. And then we say it's been turned into a plasma. Okay, now there's some special words that go with this. And so if you look at that closely at the words there, you'll see that as you go from a solid to a liquid, that's going to be referred to as melting. If you go in the opposite direction, going from the liquid back to the solid, then you're saying that you're freezing that liquid. But then, what about if you've got a liquid and then you want to go to a gas? That's going to be called evaporation. And then if it wants to go from the gas and it turns back into the liquid, that's condensation. And you could even go from a solid to a gas directly. So imagine that you have some ice cubes, and you put the ice cubes in your freezer, and then you come back a couple of weeks later, you'll notice that those ice cubes have gotten smaller. And that is because they have changed directly from a solid into a gas. Frozen CO2, so carbon dioxide, dry ice, it does the same thing. So it goes directly from a solid into a gas. So it all depends on pressure. So we won't get into that just yet. And so if it goes from the solid to the gas, then we're going to call that sublimation. And then if it goes back from the gas and it freezes and it turns back into a solid, then that's going to be called deposition. And if you go from the gas to the plasma, you have ionization. And if it goes from the plasma back into the gas form, then that's going to be deionization. So we've been discussing here that temperature will affect the state or the phase of the material. So I'm going to use those two words interchangeably, the state of the material or the phase of the material. And as we increase the temperature, it's going to change the state of the material. But also, we're going to find out that pressure can affect whether something is a solid, a liquid, or a gas, and also intermolecular forces. So in other words, carbon dioxide will be a solid at a certain temperature, and ice, water ice, will be a solid at a different temperature. And it all depends on the forces that are holding those atoms together. Okay, so, and then this is going to be called latent heat. So this one, when it's stored, is going to be called specific heat or heat capacity. And so now we're going to be talking about latent heat. So the amount of heat that it's going to need in order to change the state of a material. So let's take a break, and when we come back, let's apply some mathematics to it.